Let us discuss a very important test question on related rates and maximization of time. Here you need to review some concepts about the circles to find the distances along a straight line in a circle and along the arc. Arc length A is r times theta, and the angle subtended at the center is twice the angle on the circumference. These are the two things important to understand. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a very interesting application question based on related rates and optimizations, a combination of both. So in this playlist of calculus, you'll find many videos which are application based and are seen commonly in exams. I'd like you to review each one of them carefully. The question here is, Anil is enjoying a holiday at a circular lake. He can row the boat at 2 kilometers per hour and walk at 5 kilometers per hour. What is the longest possible time he could take to get diagonally across if the diameter of the lake is 4 kilometers, right? So let's write down what is given to us and what we need to figure out. So we are given that rowing the boat speed is 2 kilometers per hour, walking is 5, and the diameter of the lake, which is circular, is 4 kilometers. So we are given that the velocity of rowing is 2 kilometers per hour. Velocity for walking is 5 kilometers per hour. And we are given the diameter is 4 kilometers. So that means radius will be 2 kilometers, correct? And what we need to find is maximum time. And maximum time for what? So Anil is on one end of this particular lake, let's say this point is A, and wants to reach to B, which is on the other end. So he can row across, or he could go and land somewhere here, let's say point C, and then walk along the circular path, right? So T max is the time to row plus time to walk. So that is all given to us, and we clearly understand what we need to find. So this is always the very first part of solving any word problem: sketching, relating variables, information given, and what do we need to find. So once that is clear, let us approach to solve it. Now, how do you find the time? So time is distance over speed, right? So we know time is distance over speed. So we have this little triangle here representing time, distance, and speed, right? Okay, so we know that the total time will be equal to the distance from A to C over the speed to row, right? And then walking time is arc C to B, and then velocity to walk. So we can write time as AC over rowing speed is 2, and the arc CB, the walking speed is 5. Now the question is, how do we find AC and the arc CB? Now that is a challenge for some students, and that's why I get such questions from them. The real reason is that we have really forgotten about the geometry of the circle and how do we work with it, correct? So here are a couple of things to remember. Let us say that O is the center of this particular lake. And now let's connect C to O. What are we given? We are given that the diameter is 4 and therefore the radius is 2. So all these sides are equal, right? And they are all equal to 2, correct? Now, important thing here is that we have ABC, a triangle, which is in the semicircle, right? So if I connect point C to B, in that case, what happens? I make a right angle triangle at C. Do you see that? Because in a semicircle, you always make a right angle triangle. So that gives you an idea that I can now relate with the radius given and the angle theta at A. Correct? So look here. Triangle ACB. Now in this triangle, since it is a right angle triangle, angle at A is theta. Hypotenuse is 4, right? AB is the hypotenuse, which is 4. And AC is the adjacent side. So we have cos theta equals to the adjacent side AC over the hypotenuse AB. Correct? So from here, we know what AB is. So we can find A to C. AB is equal to 4, 2 plus 2, right? Four kilometers, right? So we can cross multiply and find what AC is. So AC is basically equal to AB times cos theta. And AB is 4. So we get 4 cos theta as the length AC. Perfect. So we have found AC, which is 4 cos theta. Using right triangle ACB. Now, how do we find the arc length CB? Let's look into this on a fresh page. So let me just do this construction which we did. So we have AOC, AOB here, C is here, right? And we know that AC is equal to 4 cos theta. If angle at A is theta. Now see, what is the angle at the center? If at the circumference we have an angle of theta, then at center of the circle we have angle 2 theta. So this is an important theorem, right? So this angle is 2 theta always. So we know that the angle at COB at the center equals to 2 theta. That's the theorem. And also, if we know the angle at the center, we can find the arc length CB. So the arc length CB is going to be r theta, r times the angle. So let me write r times the angle COB, where angle is being measured in radians, right? So once again, here is the formula. If you're looking at the arc with an angle, let's say this time let me put this as phi and radius as r, then the arc length A is equals to r times the angle subtended, which is phi. And that is what we have used here. Is that clear to you? So from here, we get what CB is. So CB is r, radius is 2, and therefore the angle is 2 theta. It's 2 times 2 theta, which is 4 theta. Correct? So now we have both the arc length, which is 4 theta, and AC, which is 4 cos theta. So we can now find the time. So total time is now equal to AC divided by the speed, which is 2. So we get 4 cos theta divided by 2 plus CB, which is 4 theta divided by 5. Is that clear to you? So we get our time. So that's the formula which we were looking for, correct? So now let us simplify this and then find the derivative. So 2 cos theta here plus 4 over 5 theta. So we have the expression for time, total time taken for Anil to travel from A via C to B, rowing A to C, and then walking C to B. Okay. So on a fresh page, let's complete the solution. So we have time t equals to 2 cos theta plus 4 over 5 theta, where the angle here is theta and this is 2 theta, correct? From A to C to B. That is 4 cos theta and this is 4 theta. Divided by speed, we get the time. So differentiate with respect to theta, because that theta is going to decide at which angle should Anil row the boat, right? So we have dt over d theta is equals to derivative of cos theta is minus sine. So we get minus 2 sine theta plus 4 over 5. To maximize, we will actually equate it to 0 and find the critical number, correct? So for maximum time, what should we do? Longest possible, right, time? So we will equate it to 0. So we have 0 equals to minus 2 sine theta plus 4 over 5. So that gives us 2 sine theta equals to 4 over 5, or sine theta equals to 4 over 5 divided by 5 times 2, 10, right? So we get the value of sine theta as 4 over 10, which is 0.4. And so from here, let's continue. Theta is going to be sine inverse of 0.4. So let's use the calculator. Setting it in radians, see, the whole requirement here is to work with radians, correct? In trigonometry, all the expressions are, when you use in calculus, they should be in radians. So we have to shift sine inverse of 0.4. We get equal to 0.4115. We can approximate at this stage. You see that? So we get theta as equals to 0.4115. Now putting this in our expression, we can actually find the total time taken, correct? So now how do you say this is the maximum time? So we know that time theta could be what? The value of theta is between 0 or 90 degrees, correct? In the given situation. You should write 0 and pi, correct? As we are working in radians. So we can calculate the time for all these periods. So let's find time for 0.4115. Substituting in this particular expression, and also for 0 and pi. So let's substitute this value and find the value of cos theta. So we have cos of the angle equals to 0.91 times 2. And then to this, we'll add 4 times 0.4115 divided by 5. So we get a time which is 2.162. Let us put theta as 0 and also calculate the time. We are actually using this particular expression here, right, to calculate the time. So cos 0 is 1 and theta will be 0. That means we get 2 times 1, which is 2. And if I use pi by 2, in that case cos pi by 2 is 0. So we get 0 in the first term, and we can do pi by 2 times 4 divided by 5. So that gives us decimal value of 1.256. So that is very less. So keeping theta, so we have the maximum time as 2.16. So you can compare and see that the maximum time is 2.16 hours. Now, you need to convert this into hours and minutes, right? So what is this equal to? So 0.162 times 60 will give us in minutes, right? So let's do this part so that we get time in hours and minutes. So 0.162 times 60 gives us approximately 9.7 minutes. So let's say 10 minutes, right? So the maximum time can be 2 hours and you can say 10 minutes. Is that clear to you? So that becomes the answer for this particular question. You can see how we have done it. The idea was to relate all the distances in terms of theta. So we have 4 cos theta as this diagonal across A to C, and walking distance r theta, which gives us 4 theta, 2 times 2 theta. We know the 2 speeds, and then to check whether the time is maximum or not, we substituted the critical number and the end boundary conditions into our formula for time and then check the values. So we got the maximum time is 2.162 hours, and converting the decimal point 162 to minutes, we got 2 hours and 10 minutes as our answer. So I hope with this, the solution is absolutely clear. So it was not difficult to find the 2 expressions for the distances AC and CB, provided you remember the circle theorem and some basic concepts. So I hope that helps. Feel free to share your views and suggestions. In case you need to learn from me, you can always contact me on the email address given or check our website for more details. Thanks for your time and all the best.